Hello, and welcome to our Food as a Business seminar series, Food Safety at the Farmers Market. This presentation will focus on home canning safety, specifically water bath canning. For this webinar, the objectives are to discuss the benefits of home food preservation, evaluate the potential risk of home food preservation, identify ways to prevent foodborne illness. We preserve foods in order to extend their shelf life and prevent spoilage. There are three main types of spoilage that can occur in food. These can be microbiological, consisting of molds, yeast, and bacteria; chemical, which is primarily enzymatic. A good example here is the browning of an apple. Once you cut it, it goes through enzymatic changes. And finally, physical changes, which could include water loss over time or bruising, which may occur during harvest. For the purpose of this webinar, we are primarily discussing microbiological and to a lesser extent chemical because some of the methods we will discuss will inactivate enzymes. Microorganisms can get onto the food product during any stage. Primarily they come from the environment, the soil where the produce was grown, the land that an animal was raised, from people that are handling the product, insects, transportation from pre-harvest to post-harvest environment, and anywhere along the processing, retail, and consumer home path. Most of the organisms that come into contact with our food are harmless or are spoilage organisms. Spoilage organisms cause the food to spoil but do not make the consumer sick at all. Other organisms, called pathogens, are the ones that can make a person sick, but these do not spoil the food. These are much less prevalent. We will talk a bit more about one specific organism, Clostridium botulinum, in this webinar. We use the Fat Tom principles to consider the environment of the food product and the occurrence of bacterial growth. From here on out, we will need to qualify which of these are going to be the most important for which task. Immediately, we can disregard food because that is ultimately what we are talking about. 100% of the products that we will be talking about are food, so we can't really alter that. Additionally, time is important for bacteria, but it really isn't something that we can control directly, although our ultimate goal is to increase the amount of time needed for the bacterium to grow. Temperature is going to be a key processing method. In most cases, we will use temperature as our preservation method, either hot to kill the bacteria or cold to slow the growth of the bacteria. That leaves acidity, oxygen, and moisture. These are going to be the key three things that we use to determine how to process a product, or that we can manipulate to make a product safer. The theme in this presentation is going to be focusing on how these three components of a food affect whether a food could be a botulism risk. Clostridium botulinum is a major pathogen of concern when we discuss food preservation. This bacterium is responsible for causing botulism. Clostridium botulinum is a spore-forming bacterium, and what that means is that it can exist in two forms, either as an actively growing vegetative cell or as a spore. A spore is a shelled-off capsule that the bacterium forms in order to enable it to survive harsh environmental conditions. In the environment, Clostridium botulinum exists almost exclusively as a spore. It is very prevalent in soil and can contaminate foods that come from the soil as well as other foods. Generally, consuming the Clostridium botulinum spore will not make you sick. This is because botulism is an intoxication, which means that you have to consume the toxin to become ill. The bacterial cell will only produce the toxin when it is actively growing. Clostridium botulinum will only grow and produce the toxin under very specific conditions. There has to be no oxygen, enough moisture, and a pH above 4.6. Improperly canned foods are primarily associated with Clostridium botulinum outbreaks. This chart shows the pH scale and the level of acidity in different foods. The pH scale goes from 1, strong acid, to 14, which is considered a strong base. Most foods fall between a pH of 3 and a pH of 7. By looking at this chart, which foods are more acidic? That's right, it's at the top of the chart. When talking about food, those below a pH of 4.6 are considered acidic, and foods above 4.6 are considered low acid. Naturally acidic foods are fruits, while naturally low acid foods are vegetables as well as meat and seafood. Remember that the pH of foods is important when canning because Clostridium botulinum, a deadly bacteria, cannot grow and produce its toxin below a pH of 4.6. For foods canned above 4.6, a pressure canner must be used. Pressure allows a condition of higher temperatures to deactivate the Clostridium botulinum bacteria. Recall, low acid food products are not allowed under cottage food law because of the importance of pressure canning and meeting that requirement to inactivate the bacteria. The Clostridium botulinum organism can only grow and produce toxin at a pH above 4.6. This is why foods are classified as either high acid or low acid. To review, high acid foods that have a pH of 4.6 or less, and low acid foods are those that have a pH above 4.6. This figure illustrates the conditions of various foods and how the organism can be controlled. From left to right along the bottom of the figure, you have the foods and increasing concentrations of acidity, from berries which have a pH around 3 to fish which have a pH around 7. On both sides, there are two bacteria, one a vegetative cell and the other a cell with a spore. For foods that are on the pH scale below 4.6, a mild heat treatment, such as boiling water or water bath canning, would destroy or kill the vegetative cells. For spores that might be present, the acidity of the food would prevent the spore from germinating and growing into a vegetative cell. For foods that are above 4.6, there is not enough acid to prevent the spore from germinating, so the food must undergo a much higher heat treatment which will destroy or kill the spore. This higher heat treatment is only achieved through pressure canning or, commercially, a retort system. The goal for any food preservation method is either to control or reduce microbial growth or to destroy the microorganisms. Sometimes only one method of preservation is used, sometimes more than one. And what I have previously mentioned is called the hurdle effect. Methods that we will discuss in detail throughout this educational series are using high temperature or high heat, using low temperature or cold, removing oxygen, lowering pH, or lowering the water activity. And again, to reiterate, most of these are primarily to control Clostridium botulinum. Tomatoes and pickled products are some of the items that can be made using water bath canning. Botanically, tomatoes are considered fruits and they have a pH below 4.6 along with many other fruits. Please note that tomatoes are at the pH cutoff of 4.6 requiring acidification. Differences in varieties of tomatoes can put the selection on either side of that line. Since canning safely may be a matter of life and death, some precautions like acidification must be made to keep canned tomatoes safe. To make sure that canned tomato products are well below the pH of 4.6, citric acid or bottled lemon juice should be added to each jar before filling. Does anyone have an idea of how pickling preserves products? That's right, it's the vinegar, which is acidic, and the canning process. Does anyone remember the pH cutoff before acids are added in preservation? It's a pH of 4.6. Clostridium botulinum cannot grow below a pH of 4.6. Most foods that are pickled, including cucumbers, are naturally higher than the pH of 4.6, so we acidify them by adding vinegar. Another method of acidifying foods is fermentation, where lactic acid bacteria consume sugar and produce acid. When using either method, the pH drops below 4.6, preventing this bacterial growth that we are concerned about. To prevent other microorganisms like yeast and molds, pickled products must be processed with heat. The heat is applied in a water bath canner with a specific time-temperature combination to kill microorganisms, seal jars, and preserve for later consumption. One way to make a potentially risky food safe is to add acid to the formulation in order to decrease the pH. If you have a product that you can add an acid to in order to reduce the pH, Then you may now have created a food that can safely be processed in a boiling water bath instead of with a pressure canner. Two examples that we can talk about are salsa and pickles. First, we'll talk about salsa. Salsa is a product that primarily consists of tomatoes, which can be on the borderline of the pH of 4.6, and other low acid ingredients like peppers, garlic, and onions. When preparing a batch of salsa, it can have an acidic ingredient added to it, like lemon juice or vinegar, to drop the pH far enough below 4.6 that it can now safely be processed in a boiling water bath process. The other example is with pickles. The main ingredient in pickles is cucumbers, which are low acid vegetables. So by adding a large amount of vinegar, you can drop the pH far enough below 4.6 that they can now be safely processed in a boiling water bath process. Let's recap on some definitions. Acidified foods are low acid food preserved by the addition of an acid or an acid food to obtain a pH less than 4.6. Final product pH must be below 4.6. Mississippi State University recommends actually that a pH be below 4.2 for an additional buffer of safety with home processed products. Fermented foods are preserved naturally by lactic acid or other acids that are produced from bacteria. These precautions are simply to reiterate some of the keys to pickling safety as previously discussed. The level of acidity in a pickled product is as important to safety as it is to taste and texture. Do not alter vinegar, food, or water proportions in a recipe or use vinegar with an unknown acidity. For example, if you squeeze homemade lemon juice, it should not be used in a canning process because you do not know the acidity of your freshly squeezed lemon juice. It's very important to use commercially made and processed lemon juice. Use only recipes with tested proportions of ingredients. It is really encouraged and important to use recipes from verified sources. So sources such as the book So Easy to Preserve, National Center for Home Food Preservation, USDA Canning Guide, or the Bald Blue Book for some examples. There must also be a minimum uniform level of acid throughout the mixed product to prevent the growth of Clostridium botulinum. So the acidity needs to be below 4.6 throughout your whole can. Otherwise, you have areas in your can that you did not acidify sufficiently. Flavored vinegars are interesting products to spice up salads, sauces, and special dishes. An added plus is that they are safe and easy to make at home. Information is being included about flavored vinegars in this pickling lesson because the process is similar. Heat the vinegar to just below the boiling point using a thermometer to measure, somewhere between 190 degrees and 195 degrees Fahrenheit. The vinegar should be simmering with occasional bubbles. While heating, place the combination of herbs, fruits, vegetables, and/or spices in the desired glass jar or bottle for storage. Pour heated vinegar over flavorings, seal and cool and store undisturbed for 3 to 4 weeks. During this undisturbed storage, the flavors develop in the vinegar from the fruits, vegetables, and herbs. Once the flavors have matured, strain the vinegar or simply pick out and discard the fruit, vegetables, and herbs. Other items that you can use in water bath canning are fruit-based products. Fruit can be packed in a syrup made of water or juice and a varying amount of sugar. A higher sugar to liquid ratio creates a heavier syrup which will sweeten fruit and is often used for tart, sour fruits. Lighter syrups are good for packing fruits that are naturally sweet. Unsweetened fruit juices, such as apple, pineapple, or white grape juice, also make good packing liquids for many fruits. These can be commercial products or extracted at home by crushing fruit, simmering over low heat, and straining through cheesecloth. Pie fillings are made with sugar, seasonings, prepared fruit, often the fruit is blanched, and clear gel, which is a modified food starch. Jams, jellies, and preserves are spreadable products made with sugar and pectin. At present, only jams, jellies, and preserves are allowed under cottage food law. However, if you wanted to make the other items listed, please contact Mississippi State University Extension to further test your product for safety. Sweet spreadable fruit products often differ in composition. Jellies are made by cooking fruit juice with sugar. Jelly should be clear and translucent, firm enough to keep its shape, but still quiver when shaken. Jams are made by cooking crushed or chopped fruit with sugar. Jam is a thick spread and less firm than jelly. When spread on toast, the fruit pieces do not retain their shape. Preserves are small, whole fruits or uniformly sized pieces in a thick, slightly gelled syrup. The fruit should be plump and tender, but not broken apart or mushy. Marmalades are soft fruit jellies with small pieces of citrus peel suspended in transparent jelly. Fruit butters, think of apple butter, are made by cooking fruit pulp with sugar. Butters have a thick, spreadable consistency. They are not gelled. Currently, only jams, jellies, and preserves are allowed under cottage food law. Foods like fruit juice concentrates, jams, jellies, preserves, marmalade, marshmallows, oats, nuts, cookies, and crackers are preserved through water activity. Water activity is another key way we can control for Clostridium botulinum. The primary cutoff for water activity when we are thinking about the control of Clostridium botulinum is 0.85. Food with a water activity below 0.85 will not allow for a spore to germinate and grow into a vegetative cell. Most fresh foods, such as meat, milk, eggs, and cheeses, have a high water activity, primarily above 0.91. This range, 0.9 and above, is the range that most bacteria will grow. For this reason, 0.85 is used as a cutoff level. Below that range, primarily yeast and even more likely molds will be the primary concern. Water activity is on a scale from 0 to 1, with 1 being pure water. If substances such as sugar and salt are dissolved in water, the water in that matrix becomes less available to use by microorganisms. It essentially is tied up, and the water activity is thus reduced. The next part of this presentation will focus on the preparation for safe home food preservation, safe canning and safe storage principles, and if you are making a cottage food product, the safe sale of cottage food products in the market. Below are some important preparations necessary before beginning a preservation project. First, be sure to set aside enough time to complete the project from start to finish. Unless blanching, always wash produce before preserving by using a clean, running water source. Even fruits and vegetables which have rinds or skins should be washed before cutting, since bacteria on the outside could contaminate the inside. In addition, cut out damaged or bruised areas, which could be harboring bacteria, and remove outer leaves. Keep families and friends safe by never preserving while sick. Always wash your hands before preparing food. Keep the workspace safe by cleaning and sanitizing kitchen surfaces before beginning. Hand washing is very critical to ensure food safety of the products you're making. Remember to wash hands thoroughly with soap and warm water for at least 20 seconds. Wash hands again if anything is done that will contaminate the hands. This includes coughing, blowing the nose, eating, handling garbage, using the restroom, handling raw animal foods such as eggs, meat, fish, touching money, and, more critically, if you touch your phone. Canning is one of the most popular ways consumers preserve food in the home today. It's important to be acquainted with some terms and procedures before home canning. How is the equipment cleaned? Before filling jars with fruits or vegetables, they must be cleaned from any debris and sterilized. Jars can be cleaned using hot soapy water or in the dishwasher and need to be kept hot so they don't break when filled with hot foods ready for preservation. Jars that will be filled with foods and processed for less than 10 minutes must be sterilized. Sterilization is achieved by boiling the jars for 10 minutes, usually done in the water bath canner. Jar lids also need to be prepared and heated by following manufacturer's instructions. Head space is the amount of empty space between your food and the jar lid. The amount of head space needed depends on the food being processed. Another reason to closely follow approved recipes. Too much head space may cause an improper seal, while not enough head space could cause the food to boil out and prevent proper sealing as well. A good seal is important for keeping the food sealed off from the environment and for keeping out oxygen, which will cause spoilage organisms and pathogens to grow. Acidity is important in the prevention of bacteria called Clostridium botulinum. This is the bacteria of greatest concern when canning. This bacteria forms spores, which grow to produce a very deadly toxin. Clostridium botulinum spores will come out of their inactive state when they are put in an ideal environment. Their ideal environment includes low acidity and the absence of air. When consumed, the toxin causes botulism, a disease which causes paralysis and may result in death. pH is a measure of the acidity in foods. The pH scale is from 1 to 14, with 1 being the most acidic. In reference to foods, low-acid foods include vegetables, meat, seafood, which are above 4.6. That pH means that without the high heat of pressure canning, Clostridium botulinum spores can grow in this environment. High-acid foods include fruits and acidified foods like pickles. High-acid foods can be safely canned using a hot water bath because Clostridium botulinum cannot grow at a pH below 4.6. To kill all other bacteria and inactivate enzymes that could cause a change in color or spoilage of the food, process sealed jars for a specific time-temperature combination. This combination changes with each food, so follow standardized recipes. Another important consideration when canning is altitude. Be aware that adjustments have to be made while canning at high altitudes. Since most of Mississippi is close to sea level, altitude is not an issue in this state when canning. After processing, wait 12 to 24 hours before disturbing the jars. Test the jars for proper sealing. The button in the middle of the lid should be depressed and should not move when pushed. If the jars are not sealed, this doesn't mean the contents must be thrown away. Refrigerate the jar, if within 24 hours of processing, or reprocess those unsealed jars. For reprocessing, remove the jar's lids and check the rim for imperfections that may have caused the improper seal. If needed, change jars and use a new lid. Use the same processing time in the recipe. Please note that the quality of the canned product may deteriorate slightly when reprocessing. When reading recipes, notice that some provide instructions for water bath canning, some for pressure canning, and some with the option to use either method. In most recipes, acidic or acidified foods are water bath canned, but some can be pressure canned at an adjusted time and pressure setting. Low acid foods such as vegetables, meat, and seafood are never to be canned in a water bath canner because the temperatures do not get high enough to kill Clostridium botulinum. Time and temperature combinations are the key to killing this bacteria, the bacteria's spores, and ensuring food safety of products. The conditions and length of storage depend on the food product and the method of preservation. All food products should be stored in a clean environment away from possible water damage, household chemicals, extreme temperatures, or unsanitary conditions. Canned goods can be stored in a dark, dry location with room temperatures ranging from 50 to 70 degrees Fahrenheit. Assuming that these conditions are met, home canned foods can last 12 months. If storage temperatures go above 95 degrees Fahrenheit, spoilage could begin. Before putting any food on the shelf, always be sure to label containers with the contents and date. Please use the first in, first out method, also known as FIFO. FIFO is the method of using older items in storage before using the newer ones. This is important to ensure that food is eaten within a safe time period. While many people preserve food for themselves or as a gift for family and friends, Others have such abundance that they decide to sell their preserved food at a local farmer's market or trade fair. However, when the decision is made to sell products to the public, assurance of a high quality product is a must. By selling, a promise of a tasty and more importantly safe product is made to consumers in exchange for the money. For this reason, those that sell must abide by the stricter cottage food laws. These laws are for foods made at home that will be sold to the public. Here's an example of a cottage food label. On the label should include the home processor's name, the address the product was processed, the name of the food product, the ingredients. The ingredients should be listed in descending order, predominance of weight. Allergens must be included in an allergen statement. The allergens can either be within the ingredients, clearly stated, or you can have it as a contained statement after the ingredients. You need to include the net weight or net volume of a product. And lastly, you must include the statement made in a cottage food operation that is not subject to Mississippi's food safety regulations. This statement must be in a clear 10-point size font. If there are ever plans to sell a homemade food product, remember to deal very carefully with allergens. The United States recognizes 8 major allergens. It is important to become familiar with these allergens when making food products for others. Allergens include milk, eggs, fish, shellfish, tree nuts, peanuts, wheat, and soy. Also remember that you must list the specific commodity in dealing with tree nuts, crustacean shellfish, and fish because, for example, not everyone is allergic to the same tree nut. I might be allergic to almonds but can eat walnuts. So you must specifically include in your labeling, allergen labeling, the specific commodity included in your product. Special care should be taken when preparing food for sale. All food should be kept from contamination and spoilage during production, preparation, packaging, storage, and transportation. Purchase produce from approved sources. Protect your food from cross-contamination by raw meat, eggs, or chemicals. Package all products at home and keep them safe during transport. To keep all family members safe, all of these precautions should be followed when preserving food for the home or for others. As technology advances, we have new equipment on the market. Things like the Instapot, however, are not recommended at present to be used for canning. Also, antique pressure cookers and canners from the past should not be used for canning, as this equipment is not safe. Please use standardized recipes from the Cooperative Extension Service, the United States Department of Agriculture, or other major manufacturers of canning equipment to ensure the food preserved is safe. Avoid homemade recipes, recipes from out-of-date cookbooks, even if they are official ones, and recipes from untrained individuals. We highly recommend the book So Easy to Preserve, put out by the University of Georgia Extension Service. A wealth of knowledge and recipes can also be found on the National Center for Home Food Preservation website, which is a free resource. You may also reach out to the Mississippi State University Extension Service if you have questions about canning. Mississippi State University has a presence in all 82 counties in Mississippi. The Food as a Business seminar series is supported by Mississippi State University Extension, Southern Extension Risk Management Education, and the United States Department of Agriculture, National Institute of Food and Agriculture, under the award number 20154920024228.